So in this part of the lecture, we're going to go ahead and cover the half angle formulas. So the half angle formulas are also found in your textbook. They are on page 239. And you'll note here that there are plus and minuses in front of these square roots derived from the square root property. And the plus or the minus that you choose will depend on the quadrant of the original given values. So let's go ahead and try some of these problems. So for number 12, we're looking for the sine of 195 degrees, and we're looking for an exact answer. Now, of course, we could use the sine sum or sine difference formula that we learned in a previous lesson, but we're here to look at how to use the half angle formulas. So what we want to do is remember that 195 is half of 390. And then we can rewrite sine of 195 degrees as the sine of 390 degrees over 2, and then that's going to qualify us to use a half angle formula for sine. So here we have the half angle formula for sine, and the x now is going to be 390 degrees because we have 390 degrees over 2. So we're going to now look at this formula. I'll put it up on the board. Okay, so here's the application of the formula for this particular problem, replacing x with 390 degrees. How do we pick whether we have a plus or a minus value? Well, it's really simple. Go back to the original thing you're trying to figure out. Sine of 195 degrees, is that going to be positive or will it be negative? Which quadrant is 195 degrees in? The third quadrant, right? So because 195 degrees is in the third quadrant, then the sine value for 195 degrees is negative. So we choose the negative going forward. So then this is equal to negative 1 minus, we're going to replace cosine of 390 degrees. Now, 390 degrees is coterminal with 30 degrees, so whatever cosine 390 degrees is, it's identical to cosine of 30 degrees, and the cosine of 30 degrees is square root of 3 over 2. Okay, so we have a complex fraction here inside of a radical. So when you're multiplying the numerator and denominator by 2 to clear the complex fraction, make sure that the radical gets extended to cover the 2, okay? So we're going to multiply the numerator and the denominator now by 2. And this is going to then give us still the negative out in front, square root, and now we have 2 minus square root of 3 over 4. Now the good thing here is that the square root of 4 is 2, so then we can rewrite our answer as negative square root of 2 minus square root of 3 all over 2. Make it really clear that the square root only applies to the numerator, and make it really clear that the square root covers the 2 minus square root of 3, that the square root of 3 is inside the radical with the 2. So make it really clear in your writing where the square root goes, how far down, how far over, all of that should be really clear. Okay, now when we want to check our answer, we're going to use the degree mode on the calculator, and we get a decimal approximation for sine of 195 degrees, and then we get a decimal approximation for this radical over here. Okay, so here you see the sine 195 degrees in degree mode, decimal approximation, and then you see that I typed the fraction, and I get the exact same decimal approximation, so that confirms to me that I did this problem correctly. Here's question number 22. This is not on 237, sorry about that. This is on page 242. We are going to find the cosine of theta over 2 given a certain sine value and a quadrant. So what we want to do is go ahead and draw the third quadrant and put a triangle in there and label it. So here is my theta value. My theta value has a reference triangle with a sine theta. Negative 4 over 5 means that I go down 4, and my hypotenuse is 5. And that would mean that my missing side of the triangle is a 3, since it's a 3, 4, 5 triangle. But I want to label it as a negative 3 because we are in the third quadrant. Okay, so now I have all the information that I'll need in order to use the cosine theta over 2 formula. So just let's remind ourselves of that formula real quick. The cosine theta over 2 formula is right here, so let me put it on the board. So here is the formula right here, and now I have applied it specifically to theta. I need to choose whether this is going to be a positive or a negative. So we need to figure out where is theta over 2. What we can do is come back over here to 180 degrees less than theta less than 270 and divide that entire inequality statement by 2, and the result is that 90 degrees is less than theta over 2 is less than 135 degrees, right? If you divide everything by 2, this is what you get. So theta over 2 has to be between 90 and 135, which places it in the second quadrant. So if we're trying to find the cosine of a value in the second quadrant, that cosine value must be negative. So now I just replace the cosine of theta with negative 3 over 5. Here I have a complex fraction. I'm going to go ahead and extend this radical all the way out here, and then I'm going to multiply by a 5 over 5, and this gives us negative 5 minus 3 over 10, right? So the 5 times the 1 is 5, negative 3/5 times 5 is negative 3, and then we can further simplify this to be negative, this is 2 over 10, so 1 over 5, and when you rationalize that, you end up with negative root 5 over 5 as your answer. And here's the problem in its entirety there for you. Alright, next we're going to jump over to my open math, question number 13. So, after killing my wrist in the previous lecture, I've decided I'm not going to write on the screen here. Instead, I'll write this on the board. But here's the problem. I have the tangent, and now I need to figure out the cosine of theta over 2 given this tangent. So, it's very similar to the previous problem. I'll go through this one a lot more quickly. Okay, so here's the question. We want to again find cosine of theta over 2. So we want to start by getting that formula of, sorry, wrong page, here we go. Cosine of theta over 2 is this formula right here, so I'll go ahead and copy that up on the board. So now here is the formula on the board. What I need to do is draw a triangle. My theta is in the second quadrant, so I'll go ahead and draw a triangle in the second quadrant. I have a theta value that has a reference triangle with a tangent. Negative 9 over 40 means that I'm going to have opposite over adjacent. Now you have to figure out, is the 9 negative or is the 40 negative? Given that this is going up, this would have to be a positive value. So the 9 is positive and the 40 is negative. So make sure that you put the negative on the correct part. Very common mistake. Somebody will put the negative up with the 9 and not with the 40. Just pay attention to the fact that you're moving left and then up. Okay, so then we're going to figure out 40 squared plus 9 squared. I can't believe I'm using my calculator for this. 4, 6, 1681. Square root of 1681 I don't think is a, oh, it is a rational number. Ha! Look at that. The square root of 1681 is 41. Lo and behold, we have a Pythagorean triple. I didn't think it was too possible, but then hey, might as well check. Okay, so here we have a nice Pythagorean triple, and we will replace the cosine of theta then with negative 40 over 41. And I do need to pay attention to the fact that cosine of theta over 2 is going to end up being in a different quadrant possibly. So let's go ahead and divide everything here by 2. I end up with pi over 4 is less than theta over 2 is less than pi halves. So that means that while theta is in the second quadrant, theta over 2 has to be in the first quadrant. So cosine in the first quadrant is positive. Now here I have to get rid of the complex fraction by multiplying the numerator and the denominator by 41. This is all inside the radical. So this ends up being square root of 82 over 82 when you rationalize it. Okay. So number 46 is verify the identity. So I'll start by drawing this line, and then I can choose which side I want to work with. In general, it's best to go ahead and pick the side that has the formula. And we are looking at the side with the cotangent of x over 2, so we have a couple different formulas for tangent, but we don't have cotangent, so what do we do about that? Well, what we will do is we will rewrite this as 1 over tangent x over 2, and I can either put the squared on the outside or I could put the squared here. I have to make that choice. I'll go ahead and put it here. I don't know which one is going to be more effective. But now we get to go to the formulas. So we're going to find a tangent x over 2 formula that works for us. We actually have 2 to choose from, which is going to be maybe a little difficult, except let's look at the target where we're going, okay? We're trying to end up with a sine squared and a 1 plus cosine x quantity squared. So we have to ask which of these 2 formulas is going to look the most like that. This is 1 plus cosine x, this is 1 minus cosine x, so we want to choose the one with 1 plus cosine x. So we replace tangent of x over 2 with sine x over 1 plus cosine. Okay, so I went ahead and replaced tangent of x over 2 with sine x over 1 plus cosine x. Now I'm going to deal with the fact that this is a complex fraction. I'll just flip it over as a reciprocal. We end up with 1 plus cosine x over sine x, and this is all squared. Well, that's the same thing as what I have over here. So I can rewrite this side also as 1 plus cosine x over sine x quantity squared. This one right here can be rewritten like that, and then I am done. Okay, for the last problem, I'm actually going to do number 51. And so what I want you to do is 51. Try it first. Do it completely on your own. This is one of the assigned problems. So do this problem from your homework first. Then come back and watch the solution so that you can really learn. All right? So first of all, I'm going to see that I have a tangent of theta over 2, and I want to use one of the formulas. Keep in mind that my target, what I'm trying to get to, has a 1 plus cosine theta. So that means that when I choose my formula, I want to choose the one with a 1 plus cosine x. So I'm going to go ahead and replace tangent of theta over 2 with this second formula here. Okay, so I'm going to replace tangent of theta over 2 with what I said I was going to do. And now I'm going to square this, and I'm going to try to combine these into one fraction. So over here on the left, I will rewrite this as 1 plus cosine theta squared over 1 plus cosine theta squared. That's 1 rewritten in a form that's going to be able to combine with this second thing over here. The second part I have is sine squared theta over 1 plus cosine theta squared. Now I'm not going to expand it because I see over here that my final denominator is a 1 plus cosine theta, and so I'm going to hope that somehow in the numerator I'll be able to form a 1 plus cosine theta that will cancel with one of the 1 plus cosine theta squared, one of those in the denominator. Okay, so what I need to do is now combine this into one fraction, and when I do that, I am going to go ahead and expand this binomial to 1 plus 2 cosine theta plus cosine squared theta minus sine squared theta. So this part right here is the trinomial that results from squaring the binomial, and then I have a minus sine squared theta after that. Now, one of the things I'm observing is I'm remembering that one of the Pythagorean identities, so the basic cosine squared theta plus sine squared theta is equal to 1 can be rewritten as cosine squared theta is equal to 1 minus sine squared theta. So I have here 1 minus sine squared theta. So what I've traced here in green, 1 minus sine squared theta, can be replaced with cosine squared theta. So I'm going to go ahead and do that. And so I'll end up with cosine squared theta plus 2 cosine theta plus cosine squared theta all over 1 plus cosine theta quantity squared. All right, so I am running out of space on the board here, so I'm going to just move over here. I'm going to keep working in this direction. This numerator now can be further simplified to 2 cosine squared theta plus 2 cosine theta. The denominator is still 1 plus cosine theta quantity squared. And then from the numerator, we have a GCF of 2 cosine theta. Of course, then we have that this cosine theta plus 1 cancels with a cosine theta plus 1 in the denominator. Remember that addition is commutative, so hopefully you can see that these are the same thing. And that ends up being our answer. So this will then simplify. I'll move up here. This will further simplify then to 2 cosine theta over 1 plus cosine theta, and we are done. So that's the end of this second lecture.